Continuing from the previous video, you have a power source of 20 volts, resistance of 15 ohms. You introduce the equation of ohms, which is V equals CR. Your voltage here is 20. Your current is unknown. Your resistance is 15. So, in other words, you have to isolate C for current, which pretty much gives you 20 over 15. 20 divided by 15, guys, is 1.1, we'll say 34 amps. Now, to take this further, we can introduce the concept of power. Power originally, guys, was work over time. The base unit of work was joules, and for time is seconds. So you break these down, you have J over S. Your SI unit for this is known as a watt. Now, the idea behind time comes from your current, or you could say your amps. Amps, guys, is the rate of flow for electricity. Now, this introduces a whole different formula. The original formula for power, as I said earlier, is work over time. This will be restructured to be power equals voltage times current. So V times A, or amps, equals watts. Now, going back to the previous equation or the example, you had a voltage of 20, a current of 1.34. You bring in power. Power equals voltage of 20 times the amp of 1.34. You multiply these. You have a power output of 26.8 watts. Now, going with a parallel circuit, you have a parallel circuit with 3 resistors. Your power source here, we'll keep it as 100 volts. Each of your resistors, we can say we have 50, 10, 20. When it comes to parallel resistors, you have the idea of, similar to the the mirror equation, you have 1 over R, 1 over R, as many 1 over R as you require. These values are coming from your resistors. Then this will equal your final resistance value. So in this scenario, we have 1 over 50, 1 over 10, and 1 over 20 equals 1 over final resistance. Now you have to identify the lowest, most common denominator for these. In this case, we have 100. Now 1 over 50 becomes 2 over 100. 1 over 10 is 10 over 100. And then 1 over 20 becomes 5 over 100. So now you have 17 over 100. You introduce the final resistance. You can either cross multiply, which is 100 times 1 divided by 17, or you take this fraction, inverse it, and divide. So 100 divided by 17 equals 5.88 ohms of resistance. Now going back with the diagram, you have 100 volts. You're solving for current, and your resistance is 5.88. So you isolate for C, you divide it over 5.88. So 100 divided by 5.88 equals a current of 17.0, just to keep it short, amps. And once more, you introduce power. So P equals V times C, voltage being 100, current being 17. So it's safe to say your power for wattage is 1700. Now, as a reminder, and to explain how great the situation is, when it comes to your test coming up, you will face similar diagrams for circuits, but they will be in different values and far more complicated than the ones shown previously, and including this one. So it's safe to say you may wish to practice multiple circuits from online sources in preparation for the test coming up soon.